Okay, this video is going to cover sections 4.6 and 4.7. Okay, so first, let's look at the rules for multiplying mixed numbers. So we're going to change each mixed number to an improper fraction. So if you go back and you look at your notes, you'll see that we've done that earlier this semester, and we'll review that as we go through. And step 2, we would multiply the improper fractions and simplify to lowest terms if possible. Now, Alex is going to really want you to turn any improper fraction answers back into a mixed number. So you may want to have your calculators handy. I'm going to show you how to do all of this by hand, and I'm going to go over it with your calculator. So in this portion, when we're working with mixed numbers, there's no variables, so you're welcome to use your calculator on all of it, which will make it go much quicker for you since there's a lot of topics on fractions and Alex. So let's start with this, and again, I'll remind you how to change this over into an improper fraction. We'll do it by hand, and then I'll give you the steps for the calculator. Or you can look at your calculator cheat sheet and kind of use it from there. So the first thing that we do to change to an improper fraction is we multiply the denominator times the whole number. So 5 times 5, that's 25, plus 1 more is 26. So this becomes 26 over 5. We keep that original denominator, times, do the same thing over here. 3 times 4 is 12, plus 3 more is going to give us 15 over 4. Okay, so now that they're in improper fraction form, we can go ahead and reduce them the same way we did with regular multiplication earlier in the semester. So I can do that by dividing out common factors, either top to bottom or diagonal. So remember, it has to be a bottom with a top. So I could divide out a 5 here, and this leaves me with 3. This leaves me with 1. Now I can't take the whole 4 out of 26, but I could divide by 2, and that gives me 2 left here. And if I divide by 2 here, I have 13. So I have reduced it as much as I can. So at this point, I can multiply numerator times numerator, denominator times denominator. So 13 times 3 is going to give me 39. And 1 times 2 is 2. So this would be my improper fraction. So Alex may tell you to write it as a mixed number or integer. So that means that this is not as far as you go. You have to keep going. So to remember to change it back, we take that 39 and we divide it by 2. So 2 goes into 3 once. We subtract, we have 1 left over. We bring down our 19. 2 goes into 19 9 times. That's 18. We subtract, we have 1 left over. So remember, we write this as the whole number, the remainder over the original denominator. So the answer that Alex would be looking for would be 19.5. So let's talk about how I could do this in my calculator. So I have, again, I'll talk about the two different calculators. So if I have the TI-30 X2S Multiview, the one with the N over D key, I'd do second, then my N over D, and I put in my 5, use my arrow to move it to the right, put the 1 in, move it down, move it, put my 5 in, and move it to the right. Then I'm going to put in whatever symbols I'm using, addition, subtraction, multiplication, division. So here I'm multiplying, and then I'm going to do it again. So second, N over D, 3, move it to the right, 3, move it down, 4, move it to the right, and if I press enter, it's going to give me the improper fraction. Okay, so that gives me the 39 over 2. To shift it, I need to press the second, and then the key right next to the N over D key is that times 10 to the nth key. Okay, it's to the right of that N over D, and then enter, and that'll shift it over into that 19.5. If I'm using the ABC calculator, okay, so it'd be 5 ABC, oops, that's supposed to be a BC, and then we do 1 ABC, and then 5, and then do our sign, so here multiplication, 3 ABC, 3 ABC, 4, and if you just press enter, it likes that format as the 19.5. Okay, so we've got -6 times 3 1/3. So -6 can just be -6 over 1. And then that 3 1/3 will convert. So that 3 times 3 is 9, plus 1 is going to be 10 over 3. So now I'm ready to reduce if I can. So I could reduce by 3, divide 3 here, get 1, divide by 3 here, and get 2. So I've got -2 times 10. I have just ones in the denominator, so it's just going to become a -20. And again, feel free to use your calculator on any of these with no variables. This is just a quick way of getting the answer and moving forward. Okay, so for dividing mixed numbers, we're going to do pretty much the exact same thing we just did. So we're going to change each mixed number into an improper fraction, and then we're going to divide the fractions and simplify to lowest terms if possible. So remember, when we're dividing, after we change it to the improper fractions, we do that keep, change, flip, or we also called it KFC. Remember, we called it one or the other of these two. So this is what we do. We always flip the fraction after the division sign, and then we change it to multiplication. So we did this earlier, so we're going to be doing the same thing here. So first convert it. So that's 6 times 5, that's 30, plus 5 is 35 over 6. I'm keeping my division sign for now. 2 times 3 is 6, plus 1 is 7/3. So now I'm going to get ready to change that. So I'm going to keep my 35 over 6, change it to multiplication, and flip it and make it 3/7. So now I'm in multiplication mode, so I can reduce. You can't reduce in division, only multiplication. So I can divide out 3, I can divide out 3, and so I could divide out 7 here, and divide out 7 here. So what I have remaining is the 5 times the 1, so that gives me 5 on top, and 2 times 1, which gives me 2 on the bottom. And again, they want the answer as a mixed number. So 5 divided by 2, 2 goes into 5 twice, gives me 4, subtract. So my answer should be 2.5 as a mixed number. Okay? So again, very easy to put into your calculator. You don't have to do all of these steps, but I'm just showing you just in case. So let's do another division. So 8 times 4, that's 32. Plus 1, it's 33 over 4. And we're going to divide that by -3 over 1. Now, I'm going to keep this as 33 over 4. I'm going to change it to multiplication and then flip that to -1/3. Okay? So at this point, I'm able to reduce that 3 with a 33. So this is going to give me a -11 over 4. And again, -11 over 4 is an improper. We want a mixed number. So we take our 11 and we divide it by 4. So 4 times 2, that's 8. That's as far as we can get. And when I subtract, I get 3. And so I have, remember this was negative, so -2 and 3/4 would be my mixed number. Okay, so for addition and subtraction, we're going to do the same. There's other methods for adding and subtracting. However, they're much more complicated and involve borrowing, and we're not going to be worrying about that right now. We're just going to either use your calculator, which I highly recommend for addition and subtraction, or we're going to do it in the same way that we just did multiplication and division. So I'm still going to change these to improper fractions. So my numbers are going to get really big, which is why I recommend calculator on this. So 7 times 3, that's 21, plus 1. So I have 22 over 3. Keep my sign. 2 times 5 is 10, plus 4 is going to give me 14 over 5. Now, remember with addition and subtraction, you have to have a common denominator, and that's what makes addition so hard. So the best common denominator that I can think of would be 15. So I'm going to convert these over to 15. So 5 times 3, that's a 3. 4 times 3, that's a 3. So 4 times 3 is going to give me 42. Keep my subtraction sign in there. And then 3 times 5 is 15, so 22 times 5. So you're seeing how big these numbers are getting. So I have 110. So now I can do 110 minus 42, and keep the 15 as my denominator. So 110 minus 42 is 68 over 15. So again, improper fraction, so I'm going to have to change it. 68 divided by 15. Well, 15 goes in 4 times to give me 60 with 8 remaining. So this is going to be 4 and 8 15ths as my final answer. So again, it'd be really easy to put in 7 1/3 minus 2 4/5 into my calculator, convert it over. It's going to give me my answer right away. Okay? So one of the things it's going to have you do is round mixed numbers. So you may want to pause the video and take some notes really quickly on rounding. So there's lots of ways to round a mixed number to get it to the nearest whole number. For estimation, the way I prefer is, I think this one's pretty straightforward and simple, is we multiply just the numerator of the fraction by 2, okay? So we're going to double just the top, not the bottom, just the numerator by 2, and you're going to see in the next slide how this looks. If the new fraction is improper, then we drop the fraction portion and round the whole number up by 1. So the whole goal is we're going to get rid of all the fractions anyway and just have whole numbers. So we're just using that fraction as an estimate. So if it's improper, we're going to round up the whole number by 1. If the new fraction is still proper, so even after you multiply that numerator by 2, if it's still a proper fraction, it was a pretty small fraction, we're still going to drop the fraction portion, but this time we're going to keep the whole number the same. Okay, so you may want to pause and write down those notes before you move on. Okay, so we are going to round these to the nearest whole number. So my first step was to multiply the numerator by 2. So I'm going to multiply just the 7 by 2. So this creates a new fraction of 2 14/8. What I'm looking at is this fraction here. By multiplying by 2, it created an improper fraction. So since this is improper, I'm going to drop the fraction part and just round this to 3. So now this rounds just to 3. Okay, so let's look at the next one. I have 6 3/7. I'm going to do the same procedure, just multiply the top by 2. So I now have 6 6/7. So I'm looking at just the fraction part. This part right here is now still it's still proper, right? So because this is still proper, that means that this was a pretty small fraction. So I'm going to drop the fraction portion and keep the whole number of 6. So this is kind of a basic way on rounding, and Alex is going to ask you to round a few things. I'm not going to ask you on a test, but Alex will ask you in your homework. Okay, so what they want us to do, and this is going to be what you're going to see a lot, is you're going to estimate the sum or difference. Okay, so we're going to add or subtract this. Then we're going to find the actual result. Okay, so we can do this in either order. I'll just go ahead and do the actual result first. Now, if it were me, I would do 6 5/7 plus 10 3/5. I would add that in my calculator and get my actual result as a mixed number. Okay, so I'm going to only do this the long way for those of you who are trying to do that. So to find the actual result, I do 6 7 is 42, plus 5 is going to give me 47 over 7. Okay, 10 times 5 is 50, plus 3 is 53 over 5. Okay, so now I would need a common denominator, and I feel like my best common denominator would be 35. So I'll multiply 5 by 7 and 53 times 7. You can see these numbers are getting really big. Calculators are awesome. Okay, 7 times 5, 47 times 5. So we've got 235. So now I can add my numerators and keep my denominator. So this gives me 606 over 35. Okay, so this isn't going to be easy to estimate with, so I'm going to have to change it to a mixed number. So I'll take my 606 and divide it by 35. 35 is only going to go into 60 once. So I can subtract that, and I think that's going to give me 256. Yes, I think I can go into that about 7 times. That's 245 When I subtract, I have 11. So my actual answer is 17 and 11 over 35. So that would be my actual. Okay, so that's part of what we're needing to do. To estimate it, I'm going to take my 6 and 5/7 and my 10 and 3/5, and I'm going to do the same thing that we did before. So I'm going to multiply just the tops by 2 and see what I get. So I have 6 and 10/7, and I have 10 and 6/5. So if you look at these, this is improper and this is improper, right? So if they're improper, then that means that that 6 rounds up to a 7 and that 10 rounds up to an 11. So we're going to add those together, and I'm going to get about 18 as my estimate. Now if you look at my exact, which is 17 and 11/35, 18 is a pretty good estimate. So I'm in the ballpark, so I'm doing pretty good. Okay, so let's talk about simplifying expressions with exponents. Okay, so again, you can use your calculator, but you'd want to do it exactly the way that you see it here. So you notice that it's a parenthesis around the 1/9 with the exponent on the outside. So you want to do this exactly, or else it's not going to come out the same. So what this is saying is it's saying it's 1/9 times 1/9. So I'm multiplying those, and I'm going to get 1 over 81. Okay, same as when I have whole numbers. Now this one we want to pay attention to because we have a negative on the inside. So remember we talked about like the handcuffs and how these are holding it together. So this one, because the negative is on the inside, it is a negative 1/9 times a negative 1/9. Now those two negatives create a positive 1 over 81 again. Now in this example, the negative is on the outside, so it's not included when I repeat it. So I get one negative, and then I've got my two 1/9ths being multiplied together. So this is going to create a negative 1 over 81. So again, just really watch your signs. This one's included, but I have an odd exponent. So it's negative 4/3 times negative 4/3 times negative 4/3. So these three negatives are going to create a negative, and then 4 times 4 times 4 is 64, and 3 times 3 times 3 is 27. Okay, so just really watch your signs, watch where they're located inside or outside, and watch the number of exponents that you have. Okay, so let's talk about simplification. So in this problem, again, no variables. So if you wanted to try putting it in your calculator exactly the way that you see it, there would be no issues with that. So just pay attention to how the directions want you to write your final answer. So inside of my parentheses, I have negative 1/6 times 3/5. So I could, because I'm multiplying, go ahead and reduce. I could reduce by 3 and by 3. So this gives me a 2 and this gives me a 1. So when I multiply, and again, I'm not using the exponent yet, I've got to work inside, I've got a negative 1 over 10. So this is now going to be squared. So that means I've got a negative 1/10 times a negative 1/10. Those two negatives are going to create a positive, and I've got 1 over 100. Okay? Now this problem, you got to be careful because we all want to do 11 minus 6 1/3 right now, but we can't because we've got that division first. So if I put this all into my calculator using my order of operations, it'll go ahead and do it on its own. Okay, no variables, you can put the whole thing in, or you can work it out with me. So I've got 11 over 1 minus, so I've got to change this, 6 times 3, that's 18, plus 1 is going to give me 19. So I'm going to have negative 19/3, and then keep my sign division, and then this is going to be a negative 6 plus 1 is 7 over 6. Okay, now because I have division, I'm going to keep this 11 over 1, subtract, okay? I'm going to keep my 19/3 the same. I'm going to change this to time, and I'm going to flip this to 6 over 7. Okay, so really what I'm looking at here is a negative 19/3 times a negative 6/7. So that negative 19 thirds and negative 6 sevenths, I could reduce the 3 out because I'm multiplying now. This becomes a 2, this becomes a 1. So I have 11 over 1, and then this is going to become plus, right? Because negative times a negative is a positive. I've got 19 times 2, and 19 times 2 is going to give me 38. And then I've got 1 times 7, which is 7. Now, the problem is that I'm down to addition or subtraction. So I need a common denominator if I'm going to do this by hand. So between 1 and 7, my denominator should be 7. So this one can stay 38, and this one needs to multiply by 7, right? So I have 77 sevenths plus 38 over 11. So that 77 sevenths plus 38 over 11 becomes 115 over 7. Okay, so most of the time it's going to ask for a mixed number. If it doesn't, this is a fine answer. Or we could take that 115 and divide it by 7. So 7 goes into 11 just once. And we subtract. That's going to give me 4. Bring down my 5. 7 goes into 45 6 times. Subtract and we have 3. So this would be 16 and 3 sevenths as my final answer. Okay, so we talked about evaluating expressions earlier in the semester, but we can do the same thing with fractions that we did previously. So just be really careful about how you're putting everything in there and watch your signs. So I've got my 4, and I'm just going to go ahead and make it a fraction. Divided by my W, W is 2 sevenths, times my Z, which is negative 1/5. Okay, so I got to pay attention to this division right there. So I want to make this 4 over 1 times 7 over 2 times negative 1/5. So now it's all multiplication. So I can do reducing or whatever I need to do anywhere, any top with any bottom. So I could divide out 2 here and divide out 2 here. And then I could just multiply straight across the top. So I have 1 negative, so my answer will be negative. 2 times 7 times 1 is 14. Oops, do an extra line there. Should be 14. And then on the bottom, I've got 1 times 5, which is 5. So negative 14 fifths. And that would be, okay, a great answer, unless they tell you what they want it as a mixed number. And we would take 14 divided by 5. That's going to be 5 times 2 is 10 with 4 left over. So we would have negative 2 and 4 fifths as our mixed number. Okay, so just make sure you can go back and forth again, calculator. You need to go back to the beginning where I explained what the calculator steps were. You're just, the only thing that's going to change is what symbol you're putting in the middle. Okay, so the last two things I want to talk about, there's one is a complex fraction, and this is going to lead us into our last section in the fraction unit, which we'll talk about in our next video, which is about solving equations containing fractions. So a complex fraction is located inside of those equations containing fractions. So I want you to be familiar with them. It's a fraction in which the numerator and denominator contains one or more terms with fractions. Okay, that's really what a complex fraction is. So an example of one is we have 8/9, and then we have our division, and then our 7/12. Okay, and it looks like it's a big fraction. So remember that line is a fraction line or a division line. So the easiest way to work this out is if I actually think about it as division, and I do 8/9 divided by 7/12. So then that means that it's 8/9 times 12 over 7. And again, you can use your calculator. I could reduce by 3. So this is 3. If I reduce by 3 here, this is 4. And so I end up with 32 over 21. Okay, and we could change that to a mixed number if we needed to, but for now I'm just going to leave it there. Okay, so those are pretty easy. It's when I contain variables that I really want to pay attention to what I'm doing. So this one, I'm going to rewrite this as 5 over x divided by 30 over 11. So it's 5 over x, it's an x, times 11 over 30. So once I've changed it to multiplication, I'm free to reduce. So I can divide by 5, and I can divide by 5 here. And so I multiply across, and I have 11 over 6x. So some of these you can and can't do in your calculator. So again, you may want to write it out and see what you can do, but make sure you make sure that variable's in the right position. Okay, so if you want to pause and try this one and then come back and check it, that would be great. So here I have my 5, 6 divided by y over 21. So it would be 5 over 6 times 21 over y. And so let's see, I could reduce 21 and 6 by 3, so that would be a 7 and a 2. And so 5 times 7 is 35, and 2 times y is 2y. So that would be my final answer. And when you have variables, you can't have a mixed number answer. So this one couldn't be changed into a mixed number answer at all. Okay, so let's look at the last two problems here. These are just simplifying algebraic expressions, and what I want you to notice is that they have the same variable term. They both have b's. So really I'm just looking at 2/3 minus a ninth. So if I wanted to use my calculator, 2/3 minus a ninth, just keep the b on the end and I'm good. If I'm doing this by hand, then I want a common denominator, and my common denominator here is going to be 9. So I'm going to keep the 1/9. 3 multiplies by 3 to give me 9, so I multiply the top by 3, and I have 6 over 9 now. And so now that I have two fractions that have like denominators, 6 minus 1 is 5 over 9b. And that's all I'm going to do with that. So pretty straightforward, just looks a little odd, but really easy to work with. So if you want to try this one and then check back, that'd be great. So I've got 4 and 3, so my common denominator is going to be 12. Okay, so 4 times 3, 7 times 3, so I have 21 over 12y, and then over here I'm going to multiply by 4. So I have 8 over 12y. So then I'm going to add these together, so 21 plus 8 is going to be equal to 29. I'm going to keep my 12 as my denominator and y as my variable.